Hello, welcome to all. Today we are doing continuity, the most important part of the calculus. So let us define what is the continuity and how we find mathematically to find how a equations is continuous or not. So let us suppose if I draw a curve. So we have a curve y is equal to fx. This is a curve. So now this curve, if I draw the curve like this one, so it is a continuous. There is no breaking at any point on this one. So we say this is in simple language, it is continuous. So continuous, let us ever take a point of this one. This is a suppose this is a. At the point of a, when x is equal to a, when x is equal to your value y is equal to f of a. So now height of this ones will be, so this is a x variables along x-axis and y or fx will be along y-axis. So corresponding to a we have the value. So now this will be fa. So at the point of a, if I check whether the curve is breaking or not, this is a bilkul continuous है. It is not breaking at the point of this ones. It is smooth, there is no. So if I draw वन स्ट्रोक ऑफ द पेन को अगर पूरा लेके जाऊं तो स्मूथली वी कैन टेक द पेन फ्रॉम द पी टू, फ्रॉम द पी पॉइंट टू द क्यू पॉइंट. कंटिन्यूसली हम क्या कर सकते हैं, पेन को लेके जा सकते हैं, ओके, विदाउट एनी लिफ्ट ऑफ द पेन. So so we say that at the point of a the curve is continuous. So another way, if I don't say a same graph for the q, suppose if I make a small gap between the curve. Now later suppose this is the curve. So this is the curve at the point of q. At the point of there is a breaking point at the point of b. At the point of b there is a breaking point. Breaking means there is some gap here. तो ये हमारे पास एक गैप है जहाँ पे. सो तो गैप है तो इसका मतलब है यहाँ पे एट द पॉइंट ऑफ बी द कर्व इज नॉट कंटिन्यूअस. तो यहाँ पे मेरे पास एक कंटिन्यूअस नहीं मिलता. सो कंटिन्यूअस नहीं मिलता. सो सिंपल लैंग्वेज में अगर मैं क्या करूँ, एक पेन को स्टार्टिंग फ्रॉम द पॉइंट दिस टू दिस, तो यहाँ से मेरे को इस कर्व में लाने के लिए पार्ट नंबर 2. नाउ क्यू के बाद फ्रॉम क्यू टू आर लाने के लिए, ठीक है, टेकन द पेन फ्रॉम हियर, सिंगल स्ट्रोक. तो यहाँ पे मेरे को क्या करना पड़ेगा, जंप करना पड़ेगा. वी हैव टू जंप टू ओ को मेरे को क्या करना, दिस गैप को जंप करना पड़ेगा, सो दैट वी रीच इन द कर्व, इन द पार्ट ऑफ कर्व क्यू आर. तो वी से दैट एट द पॉइंट ऑफ बी देयर इज discontinuous, curve is not continuous. So a पॉइंट में आपके पास क्या था, continuous. So at a curve is continuous. Yes, at the point of b there is some dropping, some gap in the curve. We say that at the point of b it is not continuous. At x is equal to b it is discontinuous. Not continuous means discontinuous. This is the one simple examples. Now mathematically how to find the continuous and discontinuous. Let us take another examples. Now let us take another example. In this examples our function is fx is equal to 1 if x is less or equal to 0, and fx is equal to when f is greater, x is greater than 0. So now this is the graph of this one. Let us take the point x. This is the coordinate of this point on y-axis is x is 0 and y is 1. Now coordinate of this point is x 0, y is 2. So now we have drawn the curve. So yes, So let us draw the curve for when the values of x is less or equal to 0, like along this ones. The value of fx means y, the y coordinate of corresponding the y coordinate. तो when x लेस और इक्वल टू जीरो, जब x जीरो से छोटा होता है या जीरो होता है तो अवर y is equal to 1, it means that y is equal to 1 for all values of like -1, -2, -3 and goes to infinite. Value of y is 1. This is the curve which is parallel to the x-axis. Similarly, when x greater than 0, all values of x greater than 0 from 0 to infinite, not including, excluding 0, y is equal to 2. Y is equal to 2. Now this is the curve. Now this is the constant curve. So this is the graph. So here x greater than 0, not equal to 0. So we have not taken in this curve 0 is excluding to a ring. A open ring is there, and here in the upper graph x is equal to 0, we have including 0, so we have darkened this spot at x equal to 0. We have darkened, it means that x equal to 0 taken in this curve and x not equal to 0 taken in this curve. It means that, so now if I approaching if I approaching if I approach 0 at the point of 0, it seems that the curve is discontinuous, because this is another curve, this is another curve, so it is definitely discontinuous, not continuous. So we have to prove it mathematically, like using the limits. So if I take a nearby point of if I take nearby point of 0 from the left hand side, like minus 0.01, minus 0.001, like this one. So corresponding value of when x less equal to 0, the corresponding value approximately will be y equal to 1. Y will be here 1. Y is equal to 1. All values of x which is less than 0 along this ones. I have taken some values minus 0.1 and minus 0.01. It means these points are in this area from approaching nearby of 0. Corresponding value is y. So I have taken y equal to 1. So similarly, if I take values like plus 0.001, 0.000 is 1 from the right part of the x-axis at nearby of x equal to 0. So we look at that the graph, this is y equal to here, y or fx is equal to 2, y or fx is equal to 2. So if I approach, it means that in the language of the limit, if I approaching 0 from the left hand side, its a value comes out 1. If I approach 0 from the right hand side toward the origin, our value is y equal to 1. It means that y equal to 1. So our left hand limit is here, left hand limit at x is equal to 0, is 1, and similarly right hand limit at x is equal to 0 is 2. So both limit are not equals. Also the functional value, we say that if x is equal to 0, if I put x is equal to 0, the value of fx will be, so x equal to 0, fx is equal to 1. So yes, x equal to 0 is coincided with the left hand limit. Left hand limit has the value 1, and functional value at x equal to 0 means, functional value means the value of fx at x equal to 0 is 1. So both are coinciding, left hand limit and the functional value is coinciding, but this is not equal to the right hand limit. So we say that in the language of mathematics it is not continuous. So for the continuous we have the formula. So left hand limit is equal to right hand limit is equal to the functional value. Let us suppose we are calculating left hand limit at x is equal to a. So left hand limit is equal to right hand limit is equal to functional value. Also this value should be defined not plus minus infinite. It cannot be infinite. So this is the conditions. The function should be defined at x is equal to a, and the value should not be plus minus infinite. So then we say that in the language of mathematics we say that the function is continuous. Now another case, if I take a pen, if I starting the from minus infinite to the towards zero from the negative side of this one, if I take the pen from here to here, so next from along this ones, if I go through the curve, we have to lift our pens from here to here, from here to here. When you lift the other one this one, so it means that there is a gap, at x equal to 0. We say that the function not continuous at x equal to 0, because we are not taking the pens smoothly from minus infinite to plus infinite like this, and we have just jump from here to here, then go this one. So it means that at x equal to 0, function is not continuous. So, and this is the mathematical formula: left hand limit is equal to right hand limit and equal to functional value, and this value should not be plus minus infinite, because infinite plus minus infinite not a real number. This is not a real number, that's why value should not be plus minus infinite, so other value should be there. Now another example, sir. Fx is equal to here. Now this is another example: fx is equal to 1 if x not equal to 0, and fx is equal to 1 x is equal to 0. When x is equal to 0, it means that when x is equal to 0, our value is 2, and along y-axis this is 2. So this is the value of 2, and coordinate of this point is 0, and to x is coordinate 0, y coordinate is 2, and coordinate of this point is 0 and 1, x 0 and y is 1. So now when x not equal to 0, value of y, which is also equal to fx is equal to 1. So here x not equal to 0 means I have excluding 0, not including this is. So एक रिंग हम बना देते हैं यहाँ पे, एक छोटा सा रिंग बना दिया, बिकॉज corresponding to x is equal to 0, there is no value of fx. So no values of fx. So this is the graph. So for all values from minus infinite to 0, its value is 1, and from 0 to infinite also value of fx is equal to 1. So that's why this line is this is the line from here to here, and from here to here is parallel to the x-axis. Let us discuss whether the function is continuous at x equal to 0 or not. Everywhere from minus infinite to 0, this is a continuous line, it is continuous, and from 0 to plus infinite, it is also continuous. So we have only check at the point of origin. So we have if I take our pens from minus infinite to 0, then we have just सिंगल स्ट्रोक से हम नहीं जा सकते फ्रॉम माइनस इनफाइनाइट टू प्लस इनफाइनाइट लाइक दिस वन. तो वी हैव जस्ट यहाँ पे लिफ्ट करना पड़ेगा, बिकॉज एक्स इक्वल टू 0 में एट एक्स इक्वल टू 0 वैल्यूज 2, एट एक्स इक्वल 0 वैल्यू यहाँ पे 2 आपके पास, देन गो दिस साइड, देन गो दिस साइड. वी डोंट गो सीधा हम यहाँ से ऐसे नहीं जा सकते, बिकॉज वी हैव जस्ट लिफ्ट एट एक्स इक्वल 0 ओवर पेन. तो फ्रॉम हियर देन फ्रॉम हियर just lift. So that's why at x equal 0 the function is not continuous. And another way, if I check, if I come at the point of 0 from the left hand side, taking the values nearby, very near to x equal to 0, like if I take minus 0.001, also minus 0.01, these values are nearby of 0. So we see that they are not x equal 0, they are not non-zero value of x. Corresponding value will be 1. So corresponding value of this one, so like this is minus 0.01, its corresponding value is 1. So from the left hand side we say that our limit is, the value is 1. So left hand limit, we say that in the language of the limit, left hand limit at x is equal to 0 is equal to plus 1. And now if I approaching 0 from toward the right, from the right hand side, तो near point, taken the near point of 0, x is equal to plus 0.0001, 0.001. These are the points very near to 0. So we also check from the graph fx is equal to when x not equal to 0, corresponding value is 1. Again, value of these points have the y value, fx value is again 1. So now corresponding values here y is equal to, or fx is equal to 1. So our right hand limit, we say that in the language of the limit, right hand limit. Now right hand limit is equal to right hand limit at x is equal to 0 will be 2. No, again 1. Right hand limit is again 1 because value is x, when x not equal to 0, fx is equal to 1. So right hand limit also is 1. And but your functional value fx at x is equal to 0, when x equal to 0, fx, it means that f of 0 is 2, so which is not equal to 1. So mathematically we say that left hand limit is equal to the right hand limit, and which is equal to 1, and this is not equal to our functional value. Our functional value is f0. So we say that the function is not continuous. So we say that function is not continuous. Not continuous at x is equal to 0. So in the language of mathematics we say that this one, and in the general way, in a simple language, if I take a pen from minus infinite towards plus infinite, from minus infinite, if I take the pen minus infinite to 0, then we lift the pen to go for the right part. So we say that at x is equal to 0, function is not continuous. It means that at x0 the function is, the curve is, the graph is breaking. So when the graph is breaking, we say that function not continuous. Now definition of continuity, let us define continuity in the language of mathematics. So we say that if a function fx is defined at x is equal to a, and the value of function at x is equal to a is equal to the limit of fx at x is equal to a, then the function is continuous. Then the function is continuous. And another way, if the function is not continuous, is not continuous at x is equal to a, then it is said said that the function is discontinuous function is discontinuous discontinuous at x is equal to a. So now this is our definitions. uh, so now in the language of mathematics, limit at x tends to a fx, limit of fx at a is equal to the functional value of the function at a, which is fa. And also fa should be defined. fa is defined fa is defined. It means that its value cannot be plus minus infinite. Plus minus infinite not a real number. Plus minus infinite not a real number. If so, other than that, if the value comes out, other than that, we say that the functional value is a real number. So this is the limiting value. In the we know that if this is limit value, left hand limit is equal to right hand limit. So left hand limit, both limit are included here. Left hand limit at x is equal to a is equal to our right hand limit at x is equal to a, and both values, the value cannot be, should not be plus minus infinite. So both the limit is including here. So this is the definitions, one definition of this ones. And now second definition, we defined second definitions. Now in definition 2, we define a function in its domain. Let us suppose y is equal to fx. It is our function and its domain is a closed interval. So अगर हमारे पास domain closed interval होगा तो how to define the continuous in this intervals, in this closed interval. The function fx is continuous at each point between a and b, each point of the domain, including the extreme point at x equal to a and x is equal to b also should be defined. So now first one, for the function should be continuous at each point of the closed interval a and b, including the point a and b. Including the points x is equal to a and x is equal to b. So between a and b, we already clear from the definitions one. For continuity, there should be left hand limit is equal to right hand limit is equal to functional value. So between a and b there is no problems. So the problem we have how to find the continuity at a and b. So since at the point of a, so there should be not be the left hand limit. यहाँ पे left hand limit नहीं होगा, only the right hand limit at a. So for checking the continuity at a, for continuity at x is equal to a, so we have to check only right hand limit only. Right hand limit at x is equal to a should be the functional value. तो ये हमारे पास फॉर्मूला होगा. Here this is the formula. Right hand limit at x a is equal to functional value. It means that for the right hand limit x a plus a के ऊपर प्लस आ जाएगा, fx is equal to the functional value. So we have, if both are equals and both are defined, both should be defined. fx should be defined. fx should be defined. fx is defined at x is equal to a also. So defined means the value should be plus, not plus minus infinite, other than the plus minus infinite. तो वैल्यू क्या होना चाहिए हमारे पास? रियल नंबर होना चाहिए. तो रियल नंबर, इनफाइनाइट इज नॉट ए रियल नंबर. तो सेकंड केस, if I find the limit at the point of b, so now at the point of b we have take only the left hand limit. For continuity, at x is equal to b, we have to take only the left hand limit. लेफ्ट हैंड लिमिट एट एक्स इज इक्वल टू बी. जब आप लेफ्ट हैंड लिमिट लोगे तो वी हम क्या आ जाएंगे, इस इंटरवल के अंदर आ जाएंगे. तो लेफ्ट हैंड लिमिट एट एक्स इक्वल टू बी मीन्स द वैल्यू वी आर अप्रोचिंग बी फ्रॉम द लेफ्ट टुवर्ड्स बी. So from the left, if I come taken from the left, we are inside of this intervals. So left hand limit at x is equal to b is equal to the functional value. Functional value in the language of limit x tends to b minus of fx is equal to the functional value. Also the fx should defined at fx is defined at x is equal to b. So यहाँ पे x should be defined होना चाहिए. तो x की वैल्यू defined means real number होना चाहिए. There should be a real number. So there is no sense if I take अगर यहाँ पे if I take the right hand limit, तो अगर मैं right hand limit लूंगा b plus लूंगा approaching b from toward the right. तो toward the right we are come outside of this intervals. So for the right hand limit at the point of b we will be outside of this interval, so we will not take this. Similarly, if I take left hand limit at the point of a, so if I take left hand limit at the point of a, so we are approaching a from the left hand side. It means that from the outside of the interval के बाहर से हम क्या कर रहे हैं, a की तरफ अप्रोच कर रहे हैं, इसलिए we will not take left hand limit for checking the continuity at the point of a. That's why we have taken only the right hand limit at x equal to a and left hand limit at the point of b. So these are definitions for the intervals. In case of the intervals, we defines how to find the continuity at the extreme point, and other points between a and b we are using the definition number 1. So now these are the definitions, definition number 1 and 2, and इसके बाद we will study some formulas about the functions, about the continuity. Then we will do numericals from the NCERT textbook. Till then, bye bye.